Okay, this is the key to worksheet 2.2 part 3, and that's the one where you're talking about symmetry and even, odd, or neither. Okay, so number one, you're given this function g of x, which is 7x cubed minus x, and you're told that it is symmetric with respect to the origin. What you need to do is show algebraically that it is symmetric with respect to the origin. So explain your answer. Okay, so in one of the handouts you were given in this section, one of them talked about tests for symmetries on page 8 of the handouts when you went to the module where all the videos were. It's in one of those notes. So with respect to the origin, if you want to test for symmetry with respect to the origin, it says this: replace x by negative x and y by negative y in the equation. If an equivalent equation results, in other words, if what you end up with is the same as the original, then it is symmetric with respect to the origin. Okay, so I am telling you that it is symmetric with respect to the origin. So what you have to do is replace x with negative x, y with negative y, and you better get an equation which you end up with. You better get the equation that looks like the original. And then also these are the tests for x-axis and y-axis. So to test for x-axis symmetry, you replace y with negative y. And if it is symmetric with respect to the x-axis, what you end up with will be the same as the original. For y-axis, replace x with negative x. What you end up with should be the same as the original. Okay? All right, so let's do this one. So first of all, let's go ahead and rewrite g of x as y. So I get y equals 7x cubed minus x. So I'm going to replace x with negative x and y with negative y. So wherever we see a y, I'm going to plug in negative y. Wherever we see an x and I see both places, I'm going to substitute negative x. So I get negative y equals 7 times, in parentheses, negative x cubed minus x, which I'm replacing with negative x. Now let's talk about what this means right here. This negative x in parentheses cubed. Negative x in parentheses cubed means negative x times itself 3 times. And so a negative x times a negative x times a negative x is a negative x cubed, looking like this, without parentheses. So this right here, if I simplify the right-hand side, I get negative y equals, this becomes 7 times a negative x cubed, and this right here becomes plus x, subtracting negative x is a positive x. But I can simplify this right here further, because a positive 7 times a negative x cubed is a negative 7x cubed. Okay? All right, and plus x. All right, now, here's what you really need to do. You really need to get that. See how y was by itself? Get y by itself now. So see how this is a negative 1 times y? So what I'm going to do is I'm going to go ahead and rewrite this. So I'm going to divide both sides by negative 1, just like this. Negative 1 divided by negative 1 is 1. 1 times y is y. All right, now here's what we get. So listen to what I'm saying. A negative 7x cubed, this is what this is, a negative 7x cubed divided by negative 1 plus x divided by negative 1. Okay? So that becomes a negative divided by negative is a positive, so that becomes 7x cubed. And this becomes a positive divided by negative is a negative, so that's just a negative x. Okay, now compare that with the original. What do you notice? Well, they're the same. They're equivalent. So according to our test for symmetry, when we replace x with negative x, y with negative y, if it is symmetric with respect to the origin, what you end up with better be the same as equal equation, better be the same equation as the original. And it is. So we can say g of x, which equals 7x cubed minus x, is symmetric with respect to the origin. Okay? All right, now let's look at even, odd, or neither. So in one of the handouts as well, so there were a couple of handouts. This one's on page 4 of 4, and that was part of the video that talked about even, odd, or neither. So a function is even and a function is odd. So in both cases, you're going to replace x with negative x. So replace x with negative x. Okay. If you plug in negative x and you get the original function back, then it's even. So what you end up with is identical to the original, is an even function. If what you end up with, every term is the opposite of the original, then it's an odd function. Okay? And if there's no relationship, then you say neither. Okay. So, so here you want to determine if it's even, odd, or neither. So regardless of what you do, remember you have in both cases you have to replace x with negative x. So replace x with negative x. First thing you're going to do, replace x with negative x. All right. So I'm going to say f of negative x is going to equal, where we see an x, I plug in negative x. So I'll get negative x to the fourth minus 2x, 2 times negative x squared plus 1. All right. So let's talk about what this is right here. So negative x to the fourth means negative x times itself 4 times. So a negative times a negative times a negative times a negative is a positive. X times x times x times x is x to the fourth. So what I have so far is this. F of negative x equals, this is just x to the fourth. Now let's talk about what this is, negative x squared. A negative x squared means a negative x times itself. A negative times a negative is a positive. X times x is x squared. So this becomes negative 2. Remember, this is x squared now, right here. So that becomes negative 2x squared. And then plus 1. All right, now compare that with the original. What do you notice? All these terms are identical. So they are equivalent. So what you found was this. You found that f of negative x is the same as f of x. That's what you found. Well, according to this, if f of negative x equals f of x, then it's an even function. So therefore, f of x is an, therefore f of x is an even function. Okay, so there were several things that you needed from those videos in that section 2.2. You needed this handout and you needed this, okay, in order to do this worksheet. Okay, so that's going to take care of section 2.2, part